you sick, twisted weather freaks, and welcome to another fun-filled, action-packed, and intellectually stimulating edition of This Week in Weather. I'm your host and meteorologist DT from Weather Risk, the commander of chaos, your colonel of confusion, your captain of catastrophe, and all-around winter weather lover. So let's talk about This Week in Weather, new edition here on this Friday evening, and we'll start out here with taking a look. A lot to talk about. We're going to review the storm here, which just happened, of course, on Wednesday. Some interesting things to point out about it, some interesting lessons to be brought to the fore, and then talk about what's may be happening for Christmas Eve. Got a lot of people excited about it, and we'll see if that happens. So let's get right to it. Slide here, take a look here at this image. You can see a picture of my smiling face from Richmond, Virginia, located here, and you can see my email, and you can see the Twitter page and the Facebook page. So there you go. All right, this here is the last update I can see on the snow reports, and the big surprise was the fact that the major snow was the really heavy snow, 30 to 40 inches, came across in this area here. So from Binghamton and far north central New York State, maybe just north of the Poconos, or including some of the Poconos, and through Albany, and then up into central Vermont and New Hampshire. That was the big surprise here for the big snows. And part of it was the models just completely missed the Phonogenetic forcing, and this going this far north, and also we had a really high snow ratio here of like 20 to 1. So that's what it was. And you can see that in the different colored dots here, on your right hand side, you can see 3 inches, 4 inches. So the dark blue is like 4 to 6 inch snows in here, and you can see they were just to the north of DC and portions of the Shenandoah Valley, and then up into the Philadelphia metro area. And here, just to review what I did here, what I was focused on. This was the last call map, as you can see, and I had shifted everything to the north. So, and you can see my 12 to 16 band. I did not have this far enough to the north. I know that. I'm not saying I did. All of this 6 to 12 should have been a little further north and up into here, and I didn't have that, and I should have. So that was a mistake. And again, the 6 to 10, that's fine, but again, you had 20 to 1 ratio, so really what you're looking at is up to 24 inches, and even that would have been underdone. Would not have gotten over 24 inches here in the storm no matter what, so I kind of screwed up on there big time. In terms of the sleet, the change over freezing rain, Shenandoah Valley, Southwest, they did pretty good with that. North of DC, they did good with that. They had an inch or two in and around the DC area before it changed. The 6 to 10 was just along Philadelphia to the north. That was good. This here was the first call map. About the same sort of thing. Not much to change there. So that worked out pretty good. In terms of the forecast and detecting this, well, this was my Twitter notification here back on December 11th. And this should alert for, likelihood of the biggest snowstorm in some portion of the Mid-Atlantic since the January 2016 blizzard. And the date of this was December 16, 17, the forecast. And you can see I had that issued on December 11th. So that was a pretty good forecast. That was, 5, 6, 7 days ahead of time, something like that. Let's see, 16, 11, 12, yeah, 6 days ahead of time. And then also, there was also this one here. Again, this was also December 11th, 4 o'clock in the afternoon. And for DC Metro, Northern Virginia, Northeast Maryland, Baltimore up to Philly, starts off with snow, goes to rain or mix for several hours, and back to heavy snow on the evening of the 16th. There was some transition back to some snow. We did get that into the morning of the 17th, so that worked out pretty good. So all in all, forecast worked out really well. My first Twitter alert on it back on December 11th, so I'm pretty happy. In regard to what happened with the models here, there was some difference in the models, and this is kind of important. I'm going to do a little more detail about this later on with another video, but what happened, this is the GFS here, you can see, and Sunday morning, this is the GFS here. Now, this came out, this was a week ahead of time. This was for Thursday, December, this was initialized, Saturday, I should say, for December 12th. And this is for the storm on Wednesday evening, both of these. And this is also Saturday, same thing here. Now, notice where both models have the low. You've got to see east of Norfolk. You see that off the coast. But that's not what happened. And you can see the difference in the short-range models here. Now, this here was the NAM, and this is Tuesday's, Monday night, early Tuesday morning. The NAM now has the low, not here, not east of Norfolk, but in central North Carolina, northeast, Rocky Mount, something like that. That's not the same thing. And as a result, the system taking a much further track north. Look at this. Instead of going off the coast, it actually goes up to the central Jersey coast before it turns to the east. And again, that is just, this sort of track is just way too far inland to keep it all snow in Philly. I even had some sleet in DC, in New York City, Baltimore, and Philadelphia, Charlottesville. That track is just the wrong track. I'm sorry, there's no way to describe it. It doesn't make a difference if you have the coldest air mass in the world. That low takes that track. You're going to go change over. Period. End of conversation. Let's move on. And we can look at some other things as well, and we can see the shift here, and this is why it's important. When you go from the medium range here, which was 5 days out, to this time frame here within 36 to 48 hours, there is often a key break point with a lot of these storms where the global models will show something and they have even very consistent, and then once you get within the 48-hour time frame, sometime around there, 48 to 60 hours, 42 hours, it can make a shift on the short range models, and it doesn't look like a big deal, but it can be really, really important. And this is a thing that I call the break point. It's when you go from the medium range to the short range. So we all know the short range is like 48 hours once the short range models start there, and the extended models are like 72 hours behind. But there's this little gap in between 48 to 72, and sometimes you can see these surprise jumps, and sometimes they can be really massive. I remember one time back in 2005, the European model GFS was hammering North Carolina and Virginia with a monster snowstorm, one of the biggest ones on record. And then when we got within 48 hours, suddenly, boom, the whole thing was a New England storm. I mean, it just freaked me out at the time. So I've learned to keep that in mind here, and that's kind of what happened with this. Now, sometimes the global models, to that interface where you go from 72 and 96, 120 to 48 hours, works seamlessly. We saw that with the January 2016 blizzard. We saw that with the December 2018 North Carolina, Virginia historic snowstorm. So it does work out sometimes, but a lot of times it doesn't. Let me show you. This here is the phonogenetic forcing. Now these models, this is from December 12th, and this is, I believe, this is the GFS. So this is all December 12th, and the upper left we have here valid for the afternoon of the 16th, and then the evening of the 16th here. This is the 7 p.m. on Wednesday. This is 1 p.m. Wednesday, 7 p.m., and this is would be 1 a.m. on a Thursday morning. Now, the purple stuff is the forcing, what we call phonogenetic forcing. That's the vertical motion of the atmosphere, and what it shows is the amount of lift and how heavy the precipitation is. So the more intense the purple color, the stronger the phonogenetic forcing and the heavier the precipitation is. So this is what, like I said, this here is a 1 p.m. on Wednesday, right? This was the GFS. Now, again, this is the forecast from 12Z. This is from December 12th, which was Saturday, I believe. So that's what this is showing here. Now you can see the forcing in Virginia, Delaware, Maryland, in Northern Virginia. Nice forcing here. Then by 7 p.m. on Wednesday, the Saturday GFS from December 12th had the heaviest forcing in Philadelphia. See that? Baltimore, Philadelphia, Central Jersey, going up to New York City. Then it had into New York City right along the coast, was pounding southern New England. So this is one of the reasons why I was thinking this was going to be a huge southern New England snowstorm. And New England did really good here. But then what happened was, that was a GFS, then the next run, the GFS came out. And look what it does. The phonogenetic forcing, now this was December 14th. So this is Monday's GFS, okay? So now we're talking Monday's GFS on 12/14. See that? And look what happens here. I'll show you in a second. There's the forcing, okay? It's developing somewhat off the coast, but also in the Shenandoah Valley. Very nice. You can see that. Then it pushes up off the Jersey coast and barely gets into Long Island. All this monster forcing is for the fish, according to the GFS, and it stays that way. And this is when the GFS was forecasting 2 inches for Boston. You remember that? Some people were freaking out over that, and they should have. This was crap. This was a ridiculous solution. This is what the GFS does when I say sometimes it forces things too far to the south and east. All of this was absolutely atrocious forecasting by the model. Gets a complete F. Then, once you got within the time frame again, short range time frame again, then the GFS on Tuesday suddenly had a clue again. And now the phonogenetic forcing, you can see all the blue purple, very nice. A lot of forcing going on here. The Shenandoah Valley, western and central Pennsylvania, Philadelphia, New Jersey, New York, Delaware, central Maryland. And then it pushes up into northeast and central Pennsylvania, north of New York City and Connecticut. This is a significant shift to the north. It actually was underdone. It should have been up here even more. But at least it finally had a clue at the right moment. So but this really was a shift back to the original solution there. It's almost the same thing. So there you go. All right, let's take a look at our teleconnections coming up here. We have our 4 teleconnections, the Eastern Pacific Oscillation, the EPO here, in the Gulf of Alaska right there. And then we have the PNA here on the West Coast. You have the Arctic Oscillation there and your NAO. So what we want to get again is always, for the East Coast snowstorm, you want to have the negative EPO, you want to have a positive PNA, which is a ridge on the West Coast. You're blocking over Greenland, your negative NAO, big block here, Greenland, and then your negative Arctic Oscillation. So as we look at our teleconnections here on the Atlantic side, the Arctic Oscillation is generally negative right through to early January. And then the NAO is also generally negative. Now the Canadian, the green you can see here, a Canadian model has it going positive, which is wrong. For some reason, I'm not sure why, but it does. And then even the GFS has it somewhat near neutral, but generally it's negative for the next 2 weeks, so that's good. And on the Pacific side here, we have the PNA pattern where we go positive, so it's a moderate ridge on the West Coast, and the EPO continues to run neutral. You can see that most of the lines here are pretty much in a neutral range, right through into early January. From the European center here, this is their extended stuff. We can see that the Arctic Oscillation, these are all 51 models, 50 models of the, I should say here, 50, that's supposed to be the number 50, of the European ensemble spread. And notice all the lines. The blue line is the mean. You can see it's trending down as it go into all through January. It is trending down towards, getting a negative Arctic Oscillation. And you can clearly see all the lines are trending in that direction. So that's good. So that's a nice trend. Okay, let's take a look what's going on operationally here. The system on December 21 on Monday is really close to being an East Coast winter storm. The problem is the timing is just not good enough. It's a little off. And this is a problem when you have La Nina. When you have La Nina, what you have is a very strong, fast flow. The flow is constantly coming in from the Pacific. Wham, wham, really fast. So as a result, it gets really hard for the model sometimes to figure out the phasing, and you also don't get a very strong ridge on the west coast of North America, which reduces your cold air supply, keeps it very marginal. So, but in this case, we have the southern piece of energy here, and then we have this northern piece here. And if these two were to phase, you would have a nice low pressure on the East Coast. It doesn't quite. And as a result, a nice trough that comes in here on Monday night, and there could be some snow showers in the mountains of North Carolina, Virginia, Western Maryland with this other piece of energy. But these two features not quite just that close to hitting it, but not quite. And you can see in the surface map. There it is. There's the two features. The one in Wisconsin, the one off the Carolina coast. 24 hours of forming a big coastal storm, but it doesn't quite happen. So it's going to be a mess. Then beyond that, what happens is, okay, we get a little reinforcing shot of cold air coming down here behind this low pressure area, some cold air coming in. The high moves off the coast, and then we get this big cold front coming in for Christmas Eve. Now this is the evening of the 23rd, so we have high pressure off the coast. So your winds are doing this, bringing up the mild air, bringing up the moisture. You have this big, strong cold front, that's monster trough here. And I'll show you how severe this trough, this thing bringing down some seriously cold air. Here's the trough. There it is. Now what happens on December 24th is the trough goes negative. You see the axis of it? It's tilted in this direction. So this is a neutral trough. Just to give you an idea what I'm talking. See how it's running in a north to south direction? See that? Here, the trough runs in a little different, not quite. It's in this alignment like this. See the tilt there in the black line. So as a result, the cold front slows down, and the GFS develops a wave of low pressure on the eastern Carolina coast. And what happens is that ejects moisture into the Arctic air, and it turns it over to snow. Now the reason it does that is because of this. We have a blocking pattern here, the North Atlantic Ocean. Into Greenland. It's not really a Greenland block. It's more like a North Atlantic block. But what it does, you can clearly see the tilt of this thing is that in this slightly negative tilt, and that allows low pressure to develop here, and then you get your rain going over to snow. So this the GFS is doing this morning. This is the early morning GFS. Here's the cold front. This is 7 p.m. Christmas Eve, right? There's the Arctic front. Boom. There's the low right there. All rain here. The temperatures are falling in the 40s. It's in the 50s here. It's in the 40s along the front, and then here it's in the 20s. The cold comes blasting in here. You're getting moderate to heavy snow. You're getting ice. It freezes on contact. You get slush freezing, and then moves off the coast. Very nice looking system. It produces a few inches of snow on some of the data. So that would be nice to see on Christmas Eve. And then this is the 18Z GFS doing the same thing. It's still doing it. You can see the low is forms on the front here. There it is here, and then you get the cold air, the very strong south winds, a monster cold Arctic wind coming in behind it. It flashes over. There's anywhere from 2 to as much as 6 inches of snow on the GFS, depending on where you are. So no doubt that western and central Pennsylvania, New York State, Ohio, West Virginia, Maryland, Southwest Virginia, maybe the entire Shenandoah Valley, eastern Tennessee, western North Carolina mountains, you are going to go over to snow if this is correct. The issue is, does it happen east of Interstate 81, in the Virginia, North Carolina, Piedmont, eastern Virginia, into Philly, into DC, into Baltimore, into the Delmarva? That's the issue. Now, the European model does not have this. Okay, you can see it here. Now, the European model, this is the Friday afternoon one. Again, it does have the snow in this area in the mountains, but it falls apart and lifts up in this direction. Why? Because there's no low in the front. It does not have a low in the front. And like I said on the afternoon and midday here on my Facebook page and on the Twitter page, this low has got to form. That's what allows you to get the big snow, the rain changes to snow, and the flash freeze, and the really wintry conditions on Christmas Eve night. That's what has to happen. That low doesn't form. The European model turns out being correct. Now, the good news is that the European model is showing some of the members a low forming on the front. Okay, this is the European ensemble spread, and you can see that there are several waves of low pressure on the front here, which is not what the operational model is showing. So it is possible the GFS might be correct here. I can't rule it out. Okay. And then if we look at the GFS ensemble, okay, let me go back to the GFS ensemble here, and you can see the GFS ensemble has several areas of low pressure on the front here. So there is some support for this idea. I'm not convinced yet, but it is a possibility. It's a viable scenario. It's just too far out in time to know right now, so we'll see. Now, going further out in time, here's the European. This is a very interesting looking map. It has a closed upper low here over Missouri, but there's a blocking pattern here over the Great Lakes and another in Greenland, and you have a 50-50 low. So this would force this storm to the east on December 28, 29, and you get a major East Coast winter storm, if this is correct. This is that's a nice looking map, if that's right. So we'll see. Again, the key point here, you have to have your 50-50 low. That has to be there, and the block has to be here. Can't be over here in the North Atlantic. It's got to be over Greenland. To get those two things happening, then this big upper low over Missouri, that's headed for Virginia, and we're going to get a snowstorm. If it's, we'll see. That, like I said, that has to happen. In fact, and this is the European ensemble, and you can see that the European ensemble for the 29th has a significant negative anomaly right here, as you can see. You have a nice ridge on the west coast. Look at this. Very nice to see. Okay, the polar vortex is fairly far to the south, a nice position, and you have some sort of blocking here in the North Atlantic. I wish I was more in Greenland, but it's not bad. And you've got some sort of anomaly here, negative low pressure forming here. So this is the end of the month, December 29th, December 30th. Yeah, there's another winter storm looking like it's showing up on the horizons, if this is correct. So there you go. Longer term, the blocking looks pretty darn good. And also, we have strong indications of a sudden stratospheric warming event on the GFS. You can see here, it is showing major warming developing here, which is going to split the polar vortex, one piece here, one piece here. And then you can see it also, it's about to split here on January 2nd. And if this happens, if this red area, which is the positive anomaly, it's a bubble of warm air. If this pushes into the Arctic Circle, splits the vortex, it's going to get cold in North America big time. So we'll see. And it's going to set up a very stormy pattern. if that happens. And this, you can see just another version of it from the Met UK office, and you can see here weather charts. You can see the massive warming here over the North Pole, and what's happened is it splits the vortex. So the vortex has one center here, another center here, and this here is the warming, huge bubble of really warm temperatures pushing the Arctic and causing the Arctic oscillation to go negative in a big way. And finally, in addition to that, another reason to be somewhat bullish about the second half of January is that the MJO extended plots from the European. You can see the green dots, which are day 20. So this would take us into early January, are generally in phase 8 and in phase 1. And those are very good phases for winter weather patterns in the eastern United States during the winter months. Anyway, that's the presentation. Hopefully you'll like this week in weather. I'm host DT from Weather Risk. I'll see you on the Facebook page and on the Twitter page.